Section 3.2, Properties of Parallel Lines. Postulate 3.1, the same side interior angles postulate states that if a transversal intersects two parallel lines, so we have two parallel lines, then the same side interior angles are supplementary, meaning that our two interior angles will add up to be 180. So in this case, 4 and 5 should be supplementary, and 3 and 6 should be supplementary. The measure of angle 3 is 55. Which angles are supplementary to angle 3? And can I find the measure of all the other angles? Well, if I know that the two lines are parallel, and I know that because of the symbols here, that this symbol here means that these lines are parallel, then I automatically know that angle 8 should also be supplementary to angle 3. I also know that angle 4 should be supplementary to angle 3 because it's a linear pair. And then if angle 8 is supplementary to angle 3, so I've got 4 and 8. Well, and I also got angle 2 because angle 2 is also a linear pair with angle 3. So 2, 4, and 8 are supplementary to angle 3. Now let's see if we can find the measure of the rest of the angles. Well, if angle 3 is 55, angle 1 is also 55 because they're vertical angles. We know that 4 and 3 are supplementary, so this guy has to be 125. Vertical angles, 125 here. 8 and 3 are supplementary, so this is 125. 6 is 125 because they're vertical angles. And then 8 and 7 are supplementary, so this has to be 55. And then angle 5, also 55. Theorem 3.1, the alternate interior angles theorem. If a transversal intersects two parallel lines, then the alternate interior angles are congruent. So if you're dealing with parallel lines and you have a transversal, your alternate interior angles, so in this case 4 and 6 would be congruent, and 3 and 5 would be congruent. So for this problem, it says if angle 4 is 30, what is the measure of 3, 5, and 6? So if 4 is 30, we automatically know that the measure of angle 6 is also 30. Angles 5 and 3, well, they're supplementary to 3 and 4. So that means if angle 4 is 30, angle 3 must be 150. And then that means the measure of angle 5 is also 150. If the measure of angle 4 is 45, what other angles have measures of 45? Well, before we answer that, we need to figure out what we're talking about. So theorem 3.2, the corresponding angles theorem. If a transversal intersects two parallel lines, so we've got parallel lines again, then your corresponding angles are congruent. So remember, these are the angles that are in the same general location in the 4 angle groupings. So in this case, like 2 is in the top right of its 4 angle grouping, and angle 6 is in the top right. Since we have parallel lines, 2 and 6 would be congruent. 4 and 8 would be congruent to each other. 1 and 5. And 7 and 3. So back to the question, it says if angle 4 is 45, what other angles measure 45? Well, I know that angle 8 has to because it's corresponding. I also know that angle 2 should because it's vertical to angle 4. It's a vertical angle. And angle 6 must as well because it's a vertical angle to angle 8. Theorem 3.3, the alternate exterior angles theorem. If a transversal intersects two parallel lines, then the alternate exterior angles are congruent. So once again, if we have parallel lines, our alternate exterior angle pairs are congruent. So to answer the question, if angle 8 is 45, what are the measures of 2, 7, and 1? Well, if 8 is 45, 2 is also 45 because they're alternate exterior. 8 and 7 are a linear pair, so 180 minus 45 gives us 135. And angle 1 and 7 are alternate exterior, so angle 1 is also 135. Here we want to prove angle relationships. They've given us that A and B are parallel. We can see that from the diagram and as well as the statement. And we want to figure out or prove that 1 and 8 are supplementary. So like any good proof, we start with our given statement in step 1. Then we start talking about angles 1 and 5. Well, 1 and 5, if we look at their location, they're a special angle relationship. Those are corresponding angles. So congruent corresponding angles would be our reason. That's how we know they're congruent. Then we talk about the measure of angle 1 is equal to the measure of angle 5. That's just talking about congruent angles having equal measure. That step is actually almost omittable, but we'll leave it in here for now. Angle 5 and 8 are supplementary. Well, 5 and 8 are sitting on the same line. They're adjacent, so that means they are a linear pair. So definition of linear pair. Then we talk about angle 5 and angle 8 adding up to equal 180. Well, that's just the definition of supplementary, because if they're a linear pair, we know they're supplementary, so that's definition of supplementary angles. From there, they take the fact that angle 1 and angle 5 are equal, and they substitute angle 1 in for angle 5, so substitution property. And then they take the algebraic statement and turn it back into our prove statement for step 7, where they say angle 1 and 8 are supplementary. Here we're given that line L and M are parallel and A and B are parallel. And we're asked to prove that angle 1 is congruent to angle 5. Well, our first step is our given. From there, they tell us that angle 1 and 2 are congruent. Well, we know that because 1 and 2 are vertical angles, so VAT. Then they talk about 2 and 3 being supplementary. Well, if we're dealing with parallel line, those are same side interior angles. So we're going to say same side interior angles. Then they tell us 3 and 4 are supplementary as well. But if we have parallel lines here and here as well, those would also be same side interior angles. So we have the same reason used twice there. From there, they start talking about angle 2 being congruent to angle 4. Well, if we look in the previous step, notice that angle 2 is supplementary to 3 and angle 4 is supplementary to angle 3. Anytime we have two angles supplementary to the same angle, they're said to be congruent by the congruent supplements theorem. We don't use this one a lot, but when we do, it kind of stands out. All right, from there, they talk about angle 1 being congruent to angle 4. Well, we already know that angle 1 is congruent to angle 2, and we know that angle 2 is congruent to angle 4. So if they're both congruent to the same angle, they must be congruent through the transitive property. Then we get angle 4 and 5 are congruent through vertical angle theorem. And then the last step, we should notice that angle 1 is congruent to 4 and 5 is congruent to 4, so that means 1 and 5 should be congruent to each other through the transitive property once again. Here it wants to find the measure of as many angles as possible and justify our reasons. So angle 7 is 105. We know this because of vertical angle theorem. Because we have parallel lines all over the place, angles 6 and 7 are congruent at 105. That would be corresponding to angle 7. We know that angle 4 is going to be 75 in this case because it's supplementary to the 105 by same side interior, or it's a linear pair with angle 6. 1 and 4 are both 75 because they're alternate interior. Angle 8, 105, same side interior with 4. Linear pair with 2, so that means 2 is 75. Same side interior with 5 between angle 2, so we get 105 for 5. Vertical angles, we get 105 for 3. And I think we've got all the angles covered. Find the values of x and y here. So notice the parallel lines here. If that's true, and these are our lines, and these are our transversals, we've actually got two sets of same side interior angles here. So I know that the x's, if I take those two angles, I can set 2x plus x minus 12 equal to 180. For the y's, I can do the same thing. 3y plus y plus 20 equals 180. Then I'm just going to combine like terms and solve. So I've got 3x minus 12 equals 180. I'll do some algebra, and I should get x to equal 64. For the y, same idea. Combine like terms. 4y plus 20 equals 180. I'll work the algebra, and I get y to equal 40. Here it wants us to find the value of the variables. Well, once again, we have parallel lines, not vertical angles, parallel lines. If this is a right angle, I know that this is also a right angle because they're vertical angles. And if I want to here, I could use same side interior angles here. And so that means I'm going to have 90 plus 4x plus 12 equals 180. It would be my setup. There are other ways to set this one up. This just is the first one that popped in my mind. So in this case, we'll combine like terms. You'll subtract 102 and then divide by 4, and we get x to equal 19.5. The third question, we've got to find x and y. Well, I've got parallel lines again. I know that if this angle here is vertical to this angle here, that they're congruent. So this angle here could also be 3x plus 23. And then the angle, these two angles here would be same side interior angles. So to find x, I'm going to take 2x plus 12 plus 3x plus 23 equals 180. I'll combine my like terms. I get 5x plus 35 equals 180. And I should get x to equal 29. Once you know what x is, you're just going to have to plug it back in order to find y. Or you could think of it this way. So, well, either way, we have to plug it back in. So if we plug it back in here, we've got 2 times, plug it in right here, because y and 3x plus 23 are corresponding angles. All right, let's go back up here. Let's erase all this so we can get a better picture. So the y angle and the 3x plus 23 are corresponding. They should be congruent. Well, now that we know what x is, we can plug x into this expression. So 3 times 29 plus 23 gives us an angle measure of 110. So if these are truly corresponding angles and we're dealing with parallel lines, y should be equal to that angle, so y must be 110.